Today we are going to discuss AC through inductor. AC through inductor. The inductor which is connected across the AC supply. This is the AC supply. I am going to connect to the AC voltage V equals to Vm sin omega t. Then the current I which is passing through the inductor. Okay, sinusoidally varying voltage. That voltage V equals to Vm sin omega t is applied across the inductor L. Okay, inductor L. Considering the AC, pure AC through pure inductor, AC through pure inductor, then I need to find out this current, that current amount of current which is passing through the inductor. Okay, the current through inductor is given by the current through inductor is given by I equals to 1 by L integral of V dt. 1 by L integral of V dt. I equals to 1 by L. What is mean by V? V here is the voltage, applied voltage, AC voltage. V equals to Vm sin omega t. V equals to Vm sin omega t. I am going to substitute here. V equal to Vm sin omega t dt. Okay. Then I'm taking common it as a Vm by L. Vm by L sin omega t, integral of sin omega t dt, then which gives the minus cos omega t by omega, minus cos omega t by omega. Vm by this omega into L. Okay, omega L. Vm by omega L minus minus cos omega t. I am going to write it as a sin 90 minus theta. Like I am going to write sin 90 minus theta cos theta minus sin pi by 2 minus omega t. Now this current is given by I equals to Vm by omega L sin omega t minus pi by 2, sin omega t minus pi by 2, where omega L equals to XL, where omega L equals to XL, XL equal to X suffix L, XL equal to 2 pi FL. Here F is the frequency, L is the value of inductance, the value of inductance. Here I am going to write again I equals to Vm by omega L. Vm by omega L. I am going to write Vm by omega L. I am going to write I max sin omega t minus pi by 2. For the case of inductor, pure inductor case, the current lags the voltage by 90 degrees. Then I am going to write that equation Im sin omega t minus pi. Okay. Then you just see the phasor diagram. V equals to Vm sin omega t. Then which is the current I equals to Im sin omega t minus pi by 2. This is the pure inductor case. The current lags the voltage by 90 degrees. Current lags the voltage by 90 degrees. The instantaneous current we can say that the current I is lagging voltage by an angle of 90 degrees. Okay, then the same thing I am going to draw the with phasor with waveforms. This is the voltage waveform. Voltage waveform starts at 0. Voltage waveform starts at 0. That voltage waveform is given by V equals to Vm sin omega t. The current waveform again which is going to start after 90 degrees. After 90 degrees means after pi equals to pi by 2. Pi equals to pi by 2. After 90 degrees the current waveform which is going to start. The phase angle, the phase difference between this voltage and current is given by pi by 2. This is a waveform. Then I am getting the voltage. I know the voltage. I know the current. Then I want to find out the power. Power equals to Vi. The instantaneous voltage, instantaneous current. Power equal to Vm sin omega t. I equals to Im sin omega t minus pi by 2. Vm Im by 2. Vm by simplifying this one. Vm Im by 2. 2 sin omega t minus pi by 2. Vm Im by 2 cos omega t minus omega t plus pi by 2 minus cos omega t plus omega t minus pi by 2. This is given according to the 2 sin A sin B equal to cos of A plus minus A minus B minus A plus B, cos of A plus B. Then by simplifying this one, I am going to get Vm Im by 2 cos pi by 2 minus cos 2 omega t minus pi by 2. P, the power P equals to minus Vm Im by 2 cos 2 omega t minus pi by 2. Then I want to find out the average power during the period. Okay, 0 to 2 pi. One past half cycle, 0 to pi, pi to 2 pi, negative half cycle, which completes the one cycle. Vm Im by 2 cos 2 omega t minus pi by 2 d omega t, which gives the minus 0 to 2 pi Vm Im by 2 sin 2 omega t d omega t. That average power in the inductor is given by 0. Hence, for the pure inductor never consumes power. Pure inductor never consumes any power. Okay. Then similarly, the AC through the pure capacitor. AC through the AC through the pure capacitor. AC through the pure capacitor. Here you just see here the pure capacitor which is connected across the AC supply. This is the AC supply. That AC supply V equals to Vm sin omega t. The current I, instantaneous current which is passing through this circuit. Then here I wrote sinusoidally varying voltage V equals to Vm sin omega t is applied across the capacitor. V equals to Vm sin omega t is applied across the capacitor. The current which is passing through the capacitor, I need to find out. The current which is passing through the capacitor is C is given by I equals to C dV by dt. C dV by dt. Then what do you know? What do you know? The V equals to Vm sin omega t. V equals to Vm sin omega t. C d by dt. V in place of V, I am simply substituting the input supply voltage or applied voltage, AC voltage V equals to Vm sin omega t. C Vm. C this take common as a Vm. Okay. Vm d by dt of sin omega t, which gives the differentiation of sin omega t cos omega t omega. I am getting. Then I am going to write Vm by Vm by 1 by omega c. This omega and c I am taking down 1 by omega c into cos omega t Then further simplification, I equals to Vm by 1 by omega c sin this cos omega t. What I am going to write? Sin 90 plus theta. Sin 90 plus theta. Shall I write? Sin 90 plus theta. I am going to write. I am going to write the sin 90 plus theta. Sin 90 plus theta cos theta. Okay, sin 90 plus theta cos of omega t. I am rewriting the sin pi by 2 plus omega t. Then I further simplify. If I am going to further simplify, I equals to Vm by xc. 1 by omega c is nothing but xc, capacitive reactance xc sin omega t plus pi by 2, sin omega t plus pi by 2, where xc is the 1 by omega c. Omega means we know that 2 pi f. Omega means 2 pi f. C value c, 1 by 2 pi fc. 1 by 2 pi fc. I equals to Im sin omega t plus pi by 2. I equals to Im sin omega t plus pi by 2. Then here I am getting the capacitor current. Here the current I is leading. Here the current I is leading the voltage by 90 degrees. Here the current I is leading the voltage by 90 degrees. Then which is given by the phasor diagram. The phasor diagram represents this voltage V equals to Vm sin omega t, I equals to Im sin omega t plus pi by 2. That current is leading before voltage only. That current is leading, that means leading uh, with the 90 degrees for the pure capacitor 90 degrees leading. With the help of this phasor diagram we can understand the current leads the voltage by 90 degrees for the pure capacitor. Then comes to the waveform. Here the voltage wave starts at 0 only, 0 to pi to 2 pi. You are going to see this is given by V equals to Vm sin omega t. V equals to Vm sin omega t. Before this voltage wave only, already current wave started. That angle is at an angle. That angle is pi by 2. For the case of pure capacitor, the current leads the voltage by 90 degrees. That angle phi equals to pi by 2. Angle pi equals to pi by 2. I equals to Im sin omega t plus pi by 2. I equals to Im sin omega t plus pi by 2. We are going to write this equation. I equals to Im sin omega t plus pi by 2. Okay, waveform. After getting the power, I need to write that power equals to voltage multiplied with instantaneous voltage multiplied with instantaneous current. That voltage I am writing here V equals to, I know, Vm sin omega t. I equals to Im sin omega t plus pi by 2. By simplifying this one, Vm Im by 2 into 2 sin omega t. This sin omega t plus pi by 2. This is 90 plus theta cos omega t. I am getting 2 sin omega t cos omega t. Then power p equals to Vm Im by 2. 2 sin omega t cos omega t is 2 sin theta cos theta sin 2 theta sin 2 omega t. That in that fashion I am writing here. Then the average power in the case of capacitor is calculated during the total period 0 to pi to 2 pi. Okay, 0 to pi to 2 pi. I'm going to calculate 0 to 2 pi. I'm calculating Vm Im by 2 sin 2 omega t d omega t equals to 0. For the case of pure inductor, for the case of pure capacitor, never consumes any power. Here also the average power of the power is becomes 0. Average power becomes 0. Here we come across inductive reactance XL and capacitive reactance XC. X suffix L is inductive reactance, X suffix C is capacitive reactance. Here XL equal to omega L equal to 2 pi Fl. Okay. Inductive reactance is defined as the opposition offered by the inductance of a circuit to the flow an of an alternating current. Okay, it is clear. XL equal to 2 pi Fl. Simply remember that it is in ohms. Then capacitive reactance. Capacitive reactance is given by XC. XC equals to 1 by omega C. 1 by omega C equals to 1 by 2 pi Fc. 1 by 2 pi Fc ohms. XC. These are the capacitive reactance is defined as the opposition offered by the capacitance of a circuit to the flow of an alternating current. This is a frequency inductive reactance and frequency and a capacitive reactance. This is a frequency inductive frequency versus inductive reactance. Inductive reactance is straight line. Capacitive reactance for frequency is uh, like parabola, in shape. Okay, like parabola in shape. we are going to discuss AC through RL series circuit, RC series circuit, and RLC series circuit. We are going to discuss in the next coming classes. Thank you.